152 and 252, the state dictates the material that's supposed to be covered, at least the topics. And there is loads of time in 152 to cover all the material the state says needs to be covered. In addition, they gave us an extra 10 minutes per class. I don't know why they gave extra 10 minutes to this class and not the other classes, but they gave us an extra 10 minutes, so we will finish the material that we're supposed to cover in plenty of time. So the question is, what do we cover, what do we do afterwards? And the decision does not have to be made now, but typically the choices are we can do optics or quantum, and possibly we'll have time for both. I think I knew. Katie, your vote?
I'm going up top of your school, so objects.
So we got 2 votes for quantum and 1 for optics. And most people are just staring. So again, decision doesn't have to be made. We've got another month and a half or so before we really need to make a decision. But, all right. There was one particular semester where I had plenty of time, and the question was which one would I do? And there's one student who really wanted optics, and all the rest of them were willing to let it go. And it came down to we had basically 3 hours to do optics, and he was absent that day.
I would like out of rebellion or just by chance?
All right. Again, any questions before we sort of talk about determinants? Let's see, the equations we did, the left loop equation, so we had 5 minus 3i1 plus 2 minus 7i2 minus 1i1 equals 0. I think that was one of our equations. Then we did right loop, or full right loop, starting here at the 6.
Yes.
So we had 6 minus 10i3 plus 7i2 minus 2 equals 0, and then I1 equals I2 plus I3. I believe those were our 3 equations. All right, so determinants. So we're going to sort of put this off to the side for a moment and talk about how to do determinants. There is more than one way of doing them. The method I'm going to pick is I'm starting in the upper left-hand corner. So if I have basically a grid of 4 numbers here, I start in the upper left-hand corner and I write that down. I then sort of block out that row and that column, and what I'm left with is D. So I take the A, block them out, I'm left with the D. Minus, and you're going to alternate signs as you go. Go to the next row, because I'm just working my way over. B, I block out that row and that column, and I'm left with a C. These are not absolute value marks, these are determinants. Determinants are not absolute value. And the determinant of a single number is just that number. So this becomes A times D minus B times C. So for example, if I have 4, 1, negative 1, 3, that would be 4 times 3, or 12, minus, so it's that diagonal, the A times D, minus 1 times negative 1, and I get 13. And it seemed like when I asked last time, there were not many people who had dealt with determinants before. Who are the determinant experts?
And Jez would be recent examples.
Okay. Oh, that's for Javez?
Yes.
Oh, for both of you, okay. And then Carly. Okay. So if we have 5, negative 1, negative 1, let's make it -4. And 6. What is the determinant?
34.
So 30. Actually, 34?
30 and then.
26.
Oh, sorry, 26.
30 minus 4. 26.
And it's in the minus.
Yeah, watch those pesky minus signs. All right, 2 by 2 is relatively simple. 3 by 3 is the one that we care about. So if I have a 3 by 3, A, B, C, D, E, F, G, H, I. The process is the same. I start in the upper left-hand corner, the A. Block out that row and that column, and what am I left with? I'm left with E, F, H, I. Minus, because I alternate signs, I go to the next one, B. I block out that row and that column. What I'm left with is D, F, G, I. D, F, G, I. Plus, because I'm alternating signs as I go, C. I block out that row and that column. I'm left with D, E, G, H. D, E, G, H. Any questions about how I got this?
Do you only ever start with the top row?
No, you can start anywhere actually. The simplest is just to start in the upper left-hand corner and work way across the top.
And you only do one row?
Yes,
Okay.
that or one column actually. You can do one column.
Okay.
And I did see once, I did have a professor who started somewhere in the side and started doing this meandering thing. So, but I just do the, start in the upper left and then work my way across.
Okay.
All right, and now I'm down to the 2 by 2, so this is A times EI minus FH. So that diagonal minus that diagonal. Minus B times DI minus FG. Plus C times DH minus EG. Distributing out, I get AEI minus AFH minus BDI plus BFG plus CDH minus EG or CEG. I'm going to do something with this. This is not, I'm not putting this down like it's a formula you have to memorize. The technique I expect you to know if you're going to use this. And there are times where this is easier than the other ones. In reality, when I'm solving the system of equations, I usually start with one of the techniques and then I use another one, and then there are times I've used all three within one problem. I'm going to put the positives together. So this is AIE or AEI plus BFG plus CDH minus AFH plus BDI plus CEG. So all I did is just group the ones that were positive and group the ones that were negative. Well, AEI, that's just the diagonal. BFG, that's BF at, oops, ran out of space, so we'll start over here, G. CDH, I got C, and then, sort of run off the end, so I wrap around CDH. The negatives, I have, we'll start with CEG, that's this diagonal. BDI, that's this diagonal. And AFH is here, again, run it off the edge and pick up over here. So for a 3 by 3 determinant, if I have A, B, C, D, E, F, G, H, I. Now some people can deal with it like this, and some people just write the first two columns over again, A, D, G, B, E, H. And I just multiply down this diagonal. Those are the positives, minus those three. So let's stick in numbers. Let's see, I'm going to need to erase here, so any questions before I guess I can erase the 2 by 2. Any questions? 4, 1, 1, 2, 1, 3, 6, 8, 5. So the 3 by 3 determinant, I multiply this diagonal right here. 20 plus, we rewrite the first two columns again. So 4, 2, 6, 1, 1, 8. So I got the 4, 1, 5, so that's 20. Plus 18. Plus negative 16. Minus the other diagonal. I got negative 6. Shoot, 12 times 8.
96.
96, thank you. And then 1 times 2 times 5, plus 10. So that is 22 minus, let's see.
100?
Yeah, it's 100. Which is negative 78. Questions to hear? Katie?
What does this do?
Yep, we're about to get there. I just thought I'd do random math stuff today.
Could you explain the breakdown of the top matrix? Yeah.
This right here?
Yeah.
We're doing determinants.
Mhm.
Sometimes in a textbook you'll see DET written in front of it, but this is not an absolute value again. So I start with the upper left-hand corner, A. I block out that row and column and then see what I'm left with. I'm left with EFHI.
Okay.
EFHI. And then I alternate signs, so then negative, B is the next one. Block out that row and column, I'm left with DFGI.
Okay.
And then plus, because again, alternating signs, C. Block out that row and column, I'm left with DEGH.
Okay.
Any questions before we talk about what this has to do with anything else?
So where do those numbers come from?
I just made those numbers up.
I know, but
Oh,
after the equal.
these numbers here?
Yeah.
The positives are the diagonals going this way, so 4 times 1 times 5. And then 1 times 3 times 6, and negative 1 times 2 times 8. That's where these come from. And then the negatives going, multiplying, taking those products.
And subtract, or,
And then subtracting. So it's this one, these minus those.
but you still add those.
Yeah, you're adding all the ones that are in the negative direction, you add all the ones in the positive direction, and then subtract. Other questions at the moment? When I was teaching high school, the TI stuff hadn't come out yet or hadn't become invasive. Like cutscenes. And the teacher, there was one of the teachers at the school was doing determinants with a group, and the test was a 4x4 with it, that they had to do by hand. So it can be expanded. So if you do a 4x4, that means you're going to have the first one times a 3x3 matrix minus the second one times the 3x3 matrix times the third one times the 3x3 matrix, and so forth. And it's, it's not complicated, it's just tedious. All right, so now to apply it to this. First thing to do is we need to get this into a standard form. And so we're going to combine like terms. And I want all the ones with variables on one side and everything else on the other side. So just rearranging this is negative. I probably want some room that way, so let me work down this way. So I have negative 4i1 minus 7i2 equals negative 7. Oops. Equals negative 7. I'll put a gap there for. So technically there's a plus 0i3. That's a 0. Now I do a quick double check to make sure I didn't make a careless error. So I got negative 4i1 minus 7i2, and then at that 7 right there, I subtract, bring over. All right. Next equation. I don't have any I1s in the next equation, so that's a 0i1. Then I have 7i2 minus 10i3. And then I have 4 here, which I'll take over to the right-hand side, so it equals negative 4. In the last equation, I want to get everything on all the things with variables on one side, so I have 1i1 minus 1i2 minus 1i3 equals 0. I'm assuming that somebody in the group will notice that there's a minus sign in the wrong place, that you will let me know. As with any of these techniques, a minus sign in the wrong place will completely change the answer.
Is there a reason you only moved the constant this way?
Yes. We're about to get to it.
Okay.
Other questions? All right, so first thing, I1 is going to be a fraction of 2 determinants. The denominator, actually the denominator for all 3 of them is going to be the same. The determinant we're doing down here is just the coefficients that we have here. So it's negative 4, negative 7, 0, 0, 7, negative 10, 1, negative 1, negative 1. All I did is take the coefficients, because once I have these in the proper frame, where all the I1s are lined up, 2s are lined up, 3s are lined up, I just take the coefficients, and that is my denominator. My numerator, well, something has to be different between them. So the same denominator for all 3. The numerator is, well, which variable am I replacing? I'm replacing the first variable. Oh, sorry, reword that. I'm solving for the first variable, so I'm going to replace the first column. Well, with what do I replace it? Well, the numbers I haven't used yet. So my first column is now negative 7, negative 4, 0, and the other 2 columns are the same as they were before. Negative 7, 7, negative 1, 0, negative 10, negative 1. I2. The denominator is, well, it's the same as that. Since I'm solving for the second variable, I replace the second column. So the first 2 columns are exactly what they were, exactly the same as the denominator. But the middle one, the second column, is now negative 7, negative 4, 0.
Is this basically like matrix?
Strangely, this method was discovered before they figured out matrices. But yes, usually in math class at this point, when they do major C's, determinants come in along with it. This is known specifically as Kramer's rule, like he was a Swiss mathematician. And I've seen there's a 2-page proof to show that this actually works. Which, having done more of the mathematics that I needed for physics and engineering, and not a math major, I looked at and goes, oh, it's only 2 pages. I haven't taken the time to go through and convince myself that it actually works, other than the fact that it seems to work every time I use it. I3, the denominator is, well, the same as it was the other two. What is the numerator? Okay, so
-4, 0, 1, -7, 7, 1, -1, and then -7, -4, 0.
okay. So now let's do a little determinant stuff. Let's solve this one right here. I'm just going to rewrite the first 2 columns. And double check, make sure I got the minus signs on all the right spots. And now, multiply that diagonal, that's 28, plus that diagonal, which is 70, that diagonal, which is 0, minus that diagonal, which is 0, that diagonal, which is -40, that diagonal, which is 0. So I end up with 98 plus 40, 138. What a coincidence. There's 138 right there that we got from the second technique. I wonder what the numerator is going to be. So let's do the numerator. -7, -4, 0, -7, 7, -1. So it's 138. 138. And just for the typical stunning visual effects. 7 times, -7 times 7 times -1 is 49.
0.
Plus 0.
0.
Minus
0. -70. 28.
what did you say?
At 28?
-28.
Yeah, -28.
So I get 49 plus 98, which is 147. So I1 is 147 over 138, which is exactly what we had before. I2 numerator, give myself some room down here. We got -4, 0, 1, -7, -4, 0, 0, -10, -1, -4, there's not a parenthesis there. -4, 0, 1, -7, -4, 0. So I have -16 plus
70.
70, yeah, that is a 10 there,
0.
plus 0, minus
0. 0. 0.
that was easy, which is 54. So I2, I will assume that 54 over 138 is about 0.391. Amperes, don't forget there are units here. And then the last one, -4, 0, 1, -7, 7, -1. So we get 0 plus 28. plus 0 minus negative 49 minus 16 plus 0. So it's 28 plus 65, which is 93. So 93 over 138 amperes, which I assume is 0.674 or 675. Questions on this technique? Jeez.
Could you explain, just like with the numerators, eliminating, so if you're transitioning between the first row and the second column, could you explain how that goes?
So you mean how we got the determinant or how we got this set up?
How you got the setup.
All right. So denominator you got is just the coefficients right here.
Mm-hmm.
All right. We have this column right here that we haven't used yet. This somehow has to come into play. And so when we solve for the first variable, we replace the first set of coefficients with this.
Okay.
So that's why the second and third column are the exact same as the denominator. It's the first column that changes for the first variable.
Okay.
And then when solving for the second variable, I would make that this column the second variable. And the third, it's the third.
Got you, okay.
Other questions? All right, so we have 3 different math techniques for this first, for the one current wire. There's another technique to come up with a set of equations. There's also, in terms of math techniques, there are other math techniques. There's multiplied matrices and inverse matrices. There's graphing. There's lots of different techniques. I'm sticking with the magic power of 3. So 3 of those. So let's do a different technique to come up with the system of the set of equations. Some find it simpler, some find it harder. It really comes down to the way your mind is working at the moment you need it to work.
Did you say we were gonna have to use each of these techniques?
No, I'm presenting all of them, and my recommendation is of the 2 methods for determining the equations, pick one. Of the 3 math techniques, if you are unsure, pick one, learn it, stick with it. And if you use a calculator to solve the system of equations, just please recognize that there's not a whole lot of partial credit if you do it that way. All right, let's keep these right here. Now we're going to change this. We're now going to do the technique of one current per loop. This is also known as mesh analysis if you're looking it up elsewhere. This is one current per loop. And we have 3 loops. We have the left loop, right loop, and the whole loop. I usually just do left and right. You could do the whole thing. So on the left loop, I'm just going to either go clockwise or counterclockwise. It doesn't matter which way I do it. I'm going to establish it, and I'm going to go with it. And I'm just going to go counterclockwise, just because. And I'm going to label that I sub A, so as not to confuse it with what we have here as I sub 1. And I'm going to do the right loop instead of the whole thing, just because. And I'm going to go counterclockwise again. I'm going to call that I sub B. And now I do my voltage loops. The direction I do my voltage loops does not have to correspond to the direction I do my current loop here. I'm just gonna pick a spot and go with it. I'm gonna start here right before the 5 volt, and I'm gonna go counterclockwise. Not because my current is counterclockwise, but just because that's the way I'm going. So I have 5 minus, and I'm going across in this direction. I'm going up there, I'm going that way. So I'm starting with the 5, I'm going across my 3 ohm resistor in the direction of current, so minus 3IA. Across my battery, plus 2, because I'm going from negative to positive. Across my 7 ohm resistor, so minus 7IA. But I also have this IB right here. I have 2 different currents going across this middle resistor. Plus 7IB. Because I'm going with current on the IA and against the current of IB. And then I'm finishing my voltage loop, going across the 1 there. So minus 1IA equals 0.
So it's with the current on a resistor, it's negative.
Correct. Because resistors take away, in essence, they take away energy, usually converted into heat. Which has been demonstrated in this class several times when they have way too much voltage running through some of the resistors, and suddenly you smell something and then you see smoke coming off the resistor. The next one, I think we did the right loop last time. Let's do the whole thing this time. So I'm going to start here, and I'm going to go counterclockwise around. So I got 6 minus 10 IB minus 1 IA plus 5 minus 3 IA equals 0. And now I simplify. So I get 5 and 2, so I have 7. Minus, let's see, so those have been taken care of. I got IA, so negative 3, negative 7, negative 1, so negative 11 IA. Plus 7 IB equals 0. In the bottom one, I've got 6 and 5, so I have 11. Minus 4IA minus 10 IB equals 0. This definitely has the advantage of only 2 unknowns.